Hello guys, this is Mr. Rafapa from Somel PSA Tutoring Academy. We'll be doing cubic functions. We've compiled all the prelim papers that were written this year, 2023, and then we'll be answering the questions per province. So we are starting with Limpopo. This is what Limpopo was faced with. So I take it that I'm recording this video because we've done this content. So we'll just be going through the questions. Okay. So it's important for you to pay attention. And yeah. So we know that these guys here, when they say, why is it doing this sound? I don't like this sound. Let me do the silent and see if, yeah, I don't have the sound. Thank you. Okay, so the first thing that I know is that if I'm told, for instance, that f of -2, it is equals to 0, and f of 1 is also equal to 0, because this is the statement that I'm told. F of -2 and f of 1 is equals to 0. This means that when x is -2, y is 0. When x is 1, y is 0. So these are the x-intercepts. X-intercepts. But we know very well, this is 1.1. We know very well that a third degree function must have three x values. So if in a case where I get only 2 x values, it means the other one was repeating. And we know that the one that is repeating is the turning point. So let's check the turning point. The turning point we see as this notation. Okay, so the first turning point that we have, it's 1. So this is 1, which is 0. This is the x value of the turning point, and the other one is -1. So f of -1 is also 0. So these are turning points. So the x values of the turning point, x values, I don't know the y values, x values of turning points or stationary points are given as x equals to 1 and x equals to -1. But we know the y value when x is 1. Here is the y value when x is 1. We know the image of 1 already. The image of 1 is 0. So that means this already, I can write this as coordinate form. 1 is to 0. That means the repeating x value there, the repeating x-intercept was 1. So there was another one here. Because, you know, in a normal third degree function, if you solve for x and the two x's come identical, yeah, I think that is a good word. If you have two x values that are the same, it means that the same x value is the turning point. We can see there. So it is both an intercept and turning point, because this must have 3. And then we don't know the y value of -1 yet, but I think they gave it to us there. So they gave us the image. You see, this is not a prime. Remember, after finding when you're looking for the coordinates of turning point, you must derive this and equate this guy to 0. Okay, you equate the f of x to 0 and solve for x values. After solving for x values, you substitute them back into the original function. So here they substituted the -1 back into the original function, and they got a 4. So they were just giving us the y value of this. So these are my turning points. These are the coordinates of the turning points. And then this one, f of 0 is to 2. So the first things, these are the first things that I got. These are the second things that I got. And then the third thing that I got is f of 0 equals to 2. So what this is telling me is that when x is 0, y is 2. So this is the y-intercept. This is the y-intercept of the function. And then remember, this notation represents gradient. It represents gradient at any point. So they say gradient is negative. Remember, if I have a function like this, and I have the x value of the turning point is -1, I have the other one is 1, or I can have it like this. I have -1, I have 1. So me and you can agree that the gradient between the two turning points here, it's increasing. This is increasing. It's an increasing gradient. And then after that, what happens? After that, it's decreasing and it's decreasing. But between the turning point is increasing. But on the upper side, the one above, here, between the two turning points, the gradient is what? The gradient is decreasing. All right. So they are saying the gradient is decreasing between the two turning points. So that means they are telling us the shape of the function. So it means it will take this shape. This is the shape where the gradient is decreasing. Because if it is like this, the gradient increases between the two turning points. So I'll take this shape. Okay. So I know already how my shape will look like. So the first question, they say what? Draw the function clearly indicating coordinates of turning points and the intercepts. So I'm going to try and plot that function. So this is me plotting the function. So what are my x-intercepts? I'm starting with my x-intercepts. This is -2, 1, and 1. So this is -2, and then this is +1. Okay, and my y-intercept is 2. It's a +2. It's a +2. Let me extend this to that point. No, because there's a 4 somewhere. And then my turning point is this. The turning point is this. X is to 0 and -1 is to 4. So -1 will be here. -1 is to 4. So that will be my other turning point. Okay. So I already know the shape of the function. It will be this function. Therefore, my work now is to now plot the function. So this is me plotting the function. It must cut on +2, and then it must turn again there. So that is the function. So this is the function that we have. We can now move to the next equation that is there. Then they say determine the equation of f. So the equation of f, we have f of x, because I have all the intercepts. I'm going to use this x minus x1, x minus x2, and x minus x3. This is the formula that I'm going to use. So a, my x1, x minus, my x1 is first -2, so I'll put -2 in bracket, and then my other one is 1, but it's repeating because it is also a turning point, so that means also the other one is 1, and therefore this is a x, this times this is going to be +2, and then this is x minus 1, you can say squared. So x minus 1 squared, x plus 2, because I must solve for a. So let me solve for a first before I even go further. Let me solve for a first. So I must just find another point on the function which is not the x-intercept. So this is the point that I choose, is 0 and 2. So therefore I'm looking for a. So on the y, because this is f of x which represent y, so on the y I'll put 0. No, to 0, 2. I'll put the 2. I'll put the 2, and then on x I'll put 0. I've substituted this point. So you just find another point. Sometimes they can put a point here, x and y. You just put x on x and y on y, so that you can find your a. Therefore, 0 plus 2 is 2. So this is going to be 2. And then this is 0 minus 1 is going to be minus 1. And minus 1 squared is positive 1. So 2 times 1 is 2. So I'm having 2a and 2. Dividing both sides by 2. My a is 1. Therefore, I go back. F of x equals to a, x plus 2, and x minus 1 squared. And then my a, I can substitute my a is 1. I've just found it. And then I multiply out the brackets. So this is x plus 2. And then that is going to be x squared minus 2x plus 1 when I do the FOIL method. And then x times x squared is x cubed. That is minus 2x squared. And then plus x plus 2x squared minus 4x plus 2. Therefore, is x cubed. This cancels out. This minus this is minus 3x plus 2. So that is my f of x. So my f of x is that. So I found the function f of x. And then the next question, they are saying to me, this is number 2. This question is number 2, 1.2. And then they are saying to me, remember, I just want to bring out something. If they said here h of x is equals to f of x plus 2, and then they say find out something. So I want to highlight this. This is a vertical shift, and this is a horizontal shift. So this, they have moved the function f by 2 units up, because it's positive 2, so it goes up. But this one, it's f of x, x minus 3. So the moment it's inside, that means they've moved it horizontally, and all the time it moves the direction of the sign. So if it's negative 3, it was going to go to the right. This one is going to go to the right. So they've just taken the function that we have by 3 units to the right. Here they've taken the function that we have by 2 units up. If it's minus 2, it will be by 2 units down. So if this was plus 3, it was going to be by 3 units to the left. So this one is opposite. So minus means the positive direction, whereas the positive means the negative direction. So you need to know they are different. Okay, so they say write down the x-intercepts of g, and it's 2 marks. So you don't have to think much. You just take this function, you move it 3 units. So if I move this point 3 units to the right, it's going to be 1 plus 3. So it's going to be, this point is going to be here at 4. And then if I use this one 3 units to the right, it's going to come to this point. So this is plus 3, which is 1. And then this is plus 3, which is 4. So the x values of that point, which is 1.3, x intercepts of g of x is going to be 1:0, and then the other one 4:0, and the other one 4:0, because it's still the same function. I've not moved it up and down. I've just taken it 3 units to the right. So this still becomes the turning point. It will come here. All right. And then I think this one was a mistake. They probably wanted to say 3 here, because they always bring it like that. It cannot be, because if you see, this is our f of x function. Okay, so determine the values of p for which x cubed minus 3x plus 2 equals to p will have exactly 1 root. So here I want us to answer this function looking at this question. To answer this question looking at the function, that's what I meant. So this is x cubed minus, this is x cubed minus 3x plus 2 equals to p, and then this is f of x equals to p, because this represents our f of x function. So for this to have 1 root, I must move the function upwards, and by moving the function upwards, it's going to affect what? It's going to affect the y-intercept. You and I can agree, if I take this function, I move it vertically down, it's going to come up somewhere here. It's going to have like this if I move it vertically down. So this is going to be 1, 2, 3. It's going to be 3 roots. But if I move it up, if I move this function up, if I move this function up like this, so I will only have 1 root, because this one will never touch again the x-axis. So for me to have 1 root, I must move this function upwards, and then we'll come to the other one. So now the first thing that I'm going to do is I'm going to say x cubed minus 3x plus 2 minus p equals to 0. So this represents our y-intercept on this function against the current y-intercept. So you must always check the current y-intercept. So for me to move it up, I must say this intercept, which is 2 minus p, it must be greater than the current x-intercept, which is 2. So it must be greater than 2. So p can come that other side, which is going to be positive p, and then the sign maintains. The 2 comes that side, is going to be 2 minus 2, which is 0. So p must be less than 0. Any p that is less than 0, the function will go up. If you put p here, if let's say you put p as negative 1, when you transport negative 1 to the other side, is going to be 3. So the y-intercept will be 3. 3 is upwards, so it's going to be moved up. But if you say p is 1 and you move it to the other side, so it's going to be 2 minus 1, which is going to be 1. It's going to be this side. So we cannot afford that. Number 2, we must all know, let me shift this function. I want this point here to be a turning point here. How far apart are these two? Let me draw it just here. Let me draw it just here. I want it to be something like this. Okay, so this is going to be the turning point, which is negative 1 and 0. It was negative 1 and 4. So I've just moved this function downward by 4 units. So if I move this function downwards by 4 units, I've also moved the y-intercept downwards by 4 units. So from positive 2, if I move it 4 units down, it's going to cut on negative 2. So the y-intercept here is negative 2. Okay, so do you realize now that if I move this function further down than negative 2, I'm still going to end up with 1 root. I'm going to end up with 1 root. So now, but I must check, it's against which value? It's against minus 2. So the other p, you're going to say, remember it was x cubed minus 3x plus 2 minus p equals to 0. So I'm going to say this y value now against minus 2, no longer against 2. So I want it to be less, not greater, because if it's greater, it's going to move up, and if it's moving up, it's going to go to 3 roots. Okay, so I'm going to say 2 minus p. I want it to be less than minus 2. So the 2 comes that side, is 2 plus 2, which is 4, and then the p goes that side, is going to be positive p. So now what is my final answer? My final answer is that p must be smaller than 0, but p must be greater than 4. So this is it. Okay, so that's how you answer such type of questions. Thank you very, very much.